Good evening and welcome to Wild Ecology, a lecture I'm looking forward to very much, lecture by FUMINORI Nousaku. He's joining us from Japan, so there is a time difference that we have to take into account, which will have some effect on the procedure of this lecture. This lecture, my name is Thomas Ooms. I'm the curator of craftsmanship engagement at the Faculty of Architecture. And it is with great pleasure that we have here with us tonight, Mr. FUMINORI Nousaku, who will give what I hope and what I expect and almost certain about will be a really interesting lecture about wild ecology. At the same time, makes you think if there is any kind of soft or unwild ecology, but I'm looking forward to see that happening during the lecture. Mr. Nousaku is here on invitation by Johannes Berry and Steven Schenk, who both have Japanese connections. And it is Johannes Berry, colleague also at the Faculty of Architecture, that will profoundly introduce Mr. Nousaku. As I said, there are some differences in the protocol. Because of the time difference, there will be no Q&A at the end of this session. So after the lecture, Johannes will give a sort of closing observation, and then that will be the end of the session. But before we get there, we get 1 hour to enjoy in the presence of Mr. Nousaku, introduced by Johannes.
I guess that's my cue to jump in.
It is.
So, to give a brief introduction of Mr. Nousaku for those of you that have not had the time to read the introduction on the website. Mr. Nousaku, like Thomas said, is a Japanese architect based in Tokyo. He is currently teaching at the Tokyo Metropolitan University. He was born in Toyama, Japan in 1982, graduated from Tokyo Institute of Technology in 2005, where he also received a master's degree in 2007. He established FUMINORI Nousaku Architects in 2010 and received a doctoral degree of engineering from the Tokyo Institute of Technology in 2002. In my view, Mr. Nousaku's critical writings and architectural work pierces through the abstraction of our realities and reminds us, I am here on Earth. He is one of those rare breeds of architects who are good at writing about architecture, but also good at making architecture. This is best illustrated in his book, Edifice of the Wild, released last year, which is a compilation of his writings and architectural projects, which I highly recommend. With this realization, it is very dangerous for me to also say too much about Mr. Nousaku, because he can say it much better. So without further ado, and on behalf of the University of the KU Leuven, I'm extremely honored to welcome Mr. Nousaku for this lecture. Over to you, Mr. Nousaku.
Okay, good evening, everyone. Thank you for inviting me to this lecture series. Can I share my screen?
Yes, you can.
Can you see this screen?
Yes. Works perfectly. Thank you.
Okay. So I started my lecture. Life in a modern city depends on infrastructure, such as electricity, gas, water, and transportation and industrial products. While industrialization has improved the convenience of our lives, the origin, processing process, and disposal destination of the resources of things and energy that support our lives have become black boxes. Architecture is also built on the premise of its infrastructure and industrial systems. But in this age of climate crisis, infrastructure and services are starting to get exhausted, and we must reconfigure our lives of mass consumption. As we learned from the Fukushima nuclear accident, an overly centralized system carries risks. We know that there is a limit to the ecological footprint and that we are exceeding our biocapacity. Discovering and utilizing local resources in the city will lead to sustainable modern life. The sun can provide warmth, hot water, and even electricity. Microorganisms in the soil can break down garbage and excrement. Soil can also suppress the heat island effect. A large amount of waste is generated in cities. Dismantled and discarded building materials from construction sites can be reused as resources. Therefore, we can tap into the city's circulation of energy and materials for its buildings. Our architecture practice begins with rethink the resources of architecture and the way to make it. Instead of scrap and build, we reclaim vacant houses and reuse waste materials. We utilize natural resources such as the sun, soil, and water, and use materials that are easily returned to the soil. It is an attempt to create a self-sustaining ecological cycle in the city with our wild senses. After World War II, population growth led to massive global urbanization. A side effect of this urbanization has been the ubiquity of lifestyle defined by mass production, consumption, and disposal. Tokyo is no exception to this phenomenon and is known for its accelerated development. It is now starting to deteriorate. Since 2011, Japan's population has started to decline, creating an increase in the number of the vacant houses throughout the city. The culture of scrap and build cannot be sustainable, thereby necessitating a change. Japan has now been moving towards the use of existing building stock in its architecture. The Great East Japan earthquake and the Fukushima nuclear accident of March 2011 had a significant impact on Japanese society. Until these disasters occurred, we did not know that Tokyo's electricity power was supplied by Fukushima. This revelation made it clear that we live in a world unaware of the origins or inner workings of our surroundings. Buildings in the heart of Tokyo function as tools of economic growth. Therefore, it is essential that office buildings, tower condominiums, and other commercial facilities are in a constant state of development in order to maintain new and clean image. On the other hand, the perimeter of the city is a residential area with detached individual houses and small apartments. Due to Japan's declining population and increasing elderly demographic, and this area is becoming depopulated and seems to be decaying. In expired city, life continues without the replacement of infrastructure and services. There, waste is converted into resources and used to make small updates. The process of recycling begins, for example, from unoccupied houses, old shop fronts, neglected gardens, and abandoned offices. It is like the fungi that grow on expired food. So this project is our home and office called Holes in the House. We bought a 30-year-old building which has steel structure and 4 stories. This area called Nishioi, where it takes 5 minutes to the center by train, has not been developed due to the topography of the valley. Shinkansen and JR Yokosuka line cross this area and generate loud noises. Nishioi was the location of a munitions factory during World War II, and many workers lived in the area. The area is lined with alleys, and old wooden houses still remain. Due to the lack of clean residential zoning, Nishioi is the cheapest land in Shinagawa world. This yellow building is our home and office. There is no architect who wants to live in such a yellow house. But we decided to renovate this building by ourselves. The left is original condition. The right is the state that wall was dismantled. A temporary blue sheet is attached. This blue sheet is temporary, so air comes in. We spent about a year in this condition. Plastic windows were installed in 2018. Now the outside air is no longer blowing in. This is a picture looking up at the hall from below. Skylights on the 4th floor can be seen from the 1st floor. Light comes in from the skylight on the 4th floor. Warmed air rises through the holes. The warm air is blown to the 2nd floor by a duct. So this is the state of 1st floor after demolition. The ground floor was only covered with blue sheets. Cockroaches came in during the summer, and cold air came in during the winter. The tatami room on the 2nd floor is used for guest room. Due to COVID-19, it is now a room for Zoom meeting. This is a view of the stair from the 3rd floor. Light from the skylight is delivered to the space below through the hole. This is the living room. The ceiling was demolished and wires and lights were hanging down. This is our bedroom on the fourth floor. The ALC walls were exposed without insulation. The pellet stove was installed. Biomass energy heats the room. The top plate of the pellet stove is about 300 degrees. So I sometimes do cooking with solar heat on the rooftop. To reduce the energy consumption of the building, we insulate DIY way. There are many types of insulation materials. We initially insulated with styrofoam, which is easy for even amateur to apply. However, styrofoam is a petroleum-derived insulation material. So recently, we have been using an insulation material made of compressed wood shavings. It's called wood fiber. We also installed internal windows in the living room. This is because the windows are single-glazed aluminum sashes with little or no insulation. So this is a video thermal camera. Opening the polycarbonate panel, you can see the cold surface of a single glass. One-to-one scale model of Saito House, designed by architect Kiyoshi Seike, was made at the museum. The model was to be destroyed and discarded after the exhibition's closing. We carefully dismantled these materials from this model and used them as materials for our office. In 2018, the first floor office was insulated and the windows were added. In 2019, the floors were finished in cypress and a pellet stove was installed. And we finished the floor, put up insulation, and organized electrical wiring in 2021. In the fourth floor bedroom, the ceiling was insulated with glass wool and the walls with wood fiber. We did not have a car. We did not need a parking lot. So we gradually removed the concrete from the parking lots and converted it into garden on the soil. When the concrete was removed, the soil was dead, without worms or insects. In order to get fresh air and water to the soil, we made trenches and added bamboo charcoal, branches, and humus. The soil was regenerated without the use of chemical products. We plant trees in our garden to create a cool spot in this city, converted with asphalt and concrete. We got worms to live in our garden. We compost our vegetable scraps. Now, many plants and weeds have grown. Mycelium, which creates a network into the ground, has also emerged. This little soil garden has become a cool spot in the city. The surface temperature of asphalt can reach 50 degrees. In contrast, in a garden on the soil, the soil surface temperature is about 25 degrees. As the soil moisture is drawn up through the roots of the plants and transpired through the leaves. The cul-de-sac in front of our house is almost entirely car-free, and we hope to turn it into a green and soil path in the future. If there are soil gardens spread throughout the city, they will provide cool shade in the summer. Food scraps will be composted, and a new ecosystem will be created in the city. So our renovation is still going on. Since we have a new member of family who was born last year, we are doing security fences and nets to prevent the fall around the halls. We take coincident resources such as people, energy, and materials into the design. There is no completion in this house. The halls are physical devices for the better quality of space, but at the same time, it is a metaphor of punching the holes to the current housing industry. That premise of selling a brand new completed house and its values goes down quickly by time. So next project is to renovate a 40-year-old wooden house into residential for our grandmother and guest house. The one building was converted into three separate buildings. The existing building was partially demolished and repaired in stages to reconfigure the materials on the site. Takaoka is a countryside located in the Japan seaside. As the population of Japan is decreasing, vacant houses are increasing in rural areas. In this project, we try to reuse existing materials and reduce the size of the old house. So this is a video of process. So in the first phase, the restroom, kitchen, and the bathroom will be added to the grandmother's house. In the second phase, the roof tiles are removed from the roof and stored in the site. The structure of the roof is moved by crane. The two-story building will be dismantled. In the third phase, foundations and walls will be newly built. The roof is moved to the wall. The roof is covered with existing tiles. This is a view of the three buildings from the courtyard. The paper sliding doors and wood carving were reused for grandmother's residence. The relocated roof has been reused for the dining hall. The dining hall is also a family gathering place and is used for community events. This is a guest room with mud walls. This is an evening scene. So we painted the outside walls of the dining hall with clay. We mixed the soil, sand, straw, and pine charcoal to make the clay wall material. So our next project is a Kenori's floor house. So with modern construction methods, building is damaged to the earth. By improving these methods, we aim to create buildings that coexist with the subsoil environment and return to the earth. Most of the ground surface and waterway are covered with concrete and asphalt. The soil underneath is dry and uninhabitable. Concrete-covered rivers do not purify the water, which is cloudy with sludge and gives off a bad smell. Soil without microorganisms weakens the structure and increases the risk of landslides and other disasters. Restoring water veins and restoring the function of the microorganisms in the soil will create cycle of production and decomposition in cities. Cities with a healthy subsoil space will be resilient to disasters, have purified and clean drinking water, and will be attractive living environment for humans. The soil is the hidden commons that will support our future urban life. Aggregate structure is formed when soil particles assemble into dumpling shape. Insect, earthworms, microorganisms, secretions, and mycelium of fungus act as the glue to produce the dumpling structure. In a soil with aggregate structure, many appropriate gaps are created. Because the soil is soft and has excellent aeration and drainage, many microorganisms can thrive and plants can grow easily. In the past, houses were built with strong ground foundation that allowed air and water to permeate the soil. Modern concrete slab foundations and asphalt pavement clog the soil. The buildings in the field are built with carbonized pine piles on the stilts, designed to avoid compromising the subsoil environment underneath the building. In healthy soil, mycelium gets entangled in bubble of carbonized pine piles and provides biological reinforcement, demonstrating the validity of the traditional Japanese independent foundation. Most of today's industrial products are made of non-decomposable material that continue to pile up the ground and stay as trash. The most troublesome of them all is nuclear waste from nuclear power plants. There is no such thing as waste in natural metabolic and nutrient cycling systems. Until very recently in Earth's history, biological cycling was the only system of which every living thing on Earth was part. Eventually, industry appeared and began to disrupt the natural balance of matter. Humans have exploited the resources from the surface of the earth, concentrating and reshaping them to create a mass material that cannot be safely returned to the soil. The choice of building materials will also vary to return to the soil. In addition to building materials made from wood, natural stone, earthen walls, mycelium, straw, and hemp, we reused on straw bale construction. The straw bale house construction methods originated in the United States in the 19th century. In areas where trees did not grow, people built their houses with the byproducts of grain. In Japan, where earthquakes occur It is allowed to be built in combination with a wood structure. Straw bale has thickness of 350 millimeter. Straw bale has the same level of insulation performance as glass wool, which is nearly 3 times the insulation performance of normal Japanese wooden houses. Kenori's floor house is located in Yamanashi, Japan. Mount Fuji to the south and the southern Alps to the west of the site. The site is surrounded by masonry terrace, rice paddies, and waterways. An independent foundation is used to allow water and air to circulate through the soil. Instead of concrete, we propose a foundation made of recyclable steel plates. A high floor will keep the foundation dry, even if there is termite damage. It can be inspected immediately. About 20 people with an instructor of straw bale construction did straw piling and mud wall painting. The wooden structure is placed on an independent foundation. The roof slopes down to the south to maximize the sun's energy. So we use wheat straw for the material, carries the straw blocks, the rope of the furling stripes, piles up straw blocks, and mix clay and sand, apply the soil by hand. This is the exterior view from the south. The living room is in the center, and the bedrooms are at both ends. The 2-meter deep veranda overhangs the house. The steel plate foundation opens up the ground surface, allowing air and water to permeate into the soil. Weeds are growing around the foundation. This is a living and dining room. On the left is wall of straw and earth. A pellet stove has been installed. Shoji screens are traditional Japanese architecture elements, biodegradable materials made of wood and paper. We use shoji screens instead of chemical fabric curtains. This is a bedroom surrounded by straw and earthen walls. It is cool in summer. The windows are very thick with straw bale walls. Exterior view on the south side, a series of wooden sash connect to the veranda to the interior. The lights from the shoji screen illuminates the garden. So this is the last slide. Architecture in the urban ecosystem is not a pure and unadulterated imitation of nature, but a hybrid of resources. The understanding and interpretation of materials gained by tracking things becomes the starting point for architectural ideas. Soil is the foundation of circulation. Sun is source of energy for life. Garbage can transform into resources. The modern people underestimate the power of the sun and soil because of the availability of electricity, gas, and water through infrastructure. However, without the sun, the earth would not be dynamically stable, and without soil, decay and decomposition would not occur. Even today, we are still in between the soil, sun, and the soil. So this is all for my presentation. Thank you for listening.
Thank you so much, Mr. Nousaku. I think that, yeah, I think as everyone is aware at this moment that your work deals with such relevant aspects of our world currently. And I guess that was one of the main reasons also, at least from our point of view, of inviting you, because in our studios at the university, we also try to deal with these topics. So it is very refreshing to also have insights from a different part of the world. I think I'm particularly interested in the tools that you introduce of how to deal with these topics, and maybe time as a scale is something that I think in our studios, at least for the moment, is underexplored. So I find this very inspiring. But I think also saying that, I realized that there are many other topics in your work also that really fascinate me. And I guess for the other attendees today, it might be the case, or probably is the case also. So I think that we would really like to have a discussion. But like Thomas said in the beginning, we will have a discussion next week, Wednesday, with the students. So for the people that are attending today that cannot be there for some reason or would like to be there, I shared my email address in the comments. So please send all questions or requests there, and we will follow it up with you to have what I'm sure will be a vibrant discussion. And then we will get back to you, Mr. Nousaku, with this feedback, if I can put it that way. So,
okay, right. Thank you.
Thank you. So I understand it's very late in Tokyo. So again, we also appreciate this aspect very much, talking about scale of time. But yeah, if you have any closing remark, you do not have to. I understand it's late, but yeah, we thank you so much, and we will get back to you.
Thank you for inviting me.
Thanks a lot. Thanks everyone also for attending, and luckily this is not the end of it, so we can have a nice evening and a nice sleep, and yeah, we will take this conversation further. So now, thanks a lot.